Okay, guys, so this is for section 3, chapter 11, dot product of vectors. So what we've got here is we've got the dot product being that relationship between vectors where we can just multiply those component pieces. So all this does is it adds the products of the corresponding components of the vectors. So for example, if we've got u, that gives us something like 1, 2, and v that gives us something like 3, 4, then all we're doing to do the dot product of u and v is we're just multiplying those respective components together. So just 1 times 3 plus 2 times 4. 1 times 3 is 3. 2 times 4 is 8. So our answer is 11. Notice that the dot product of two vectors is a scalar. Okay? That's significant because later on we can manipulate that concept to make things easier for us when we do certain other activities. So the properties that you want to keep in mind on this is just like any other multiplication property. Okay? So you've got the commutative property works. So this is going to be the same as that flipped. You've got the distributive property over multiplication as well as over addition. Okay. You've got the zero property. You've also got the following property that when you take two vectors, and it's the same vector, I should say, and you do the dot product of that, what you're going to get is the magnitude squared. Okay. Now this is interesting because think about this. If the magnitude is squared, aren't you taking the square root to get this? So if you're squaring a square root, all right, you're just going to get rid of all those things, the square to square root. So, okay. Excuse me, my allergies are going crazy today. Two other things to note there is that when you've got vector v again times itself, you're also looking at it from the perspective of you've got that first component squared, second component squared, third component squared. Okay? So let's do another example. So if we've got v and it is 2i minus 3j plus k, and we've got w, which is negative I plus 2j minus 2k, and we want to do the dot product of those, then all we're going to get is 2 times negative 1, negative 3 times 2, 1 times negative 2. So when you put all that together, you get negative 10. All right? Oh, that kind of looks like a 16. There we go. Okay. Now, you can also find this by using something else, and this is called a dot product between, or the angle between two vectors. And this is for when you've got theta in between 0 and pi. What you can do is you can take the cosine of theta, and that's going to be equal to one vector times another one divided by their magnitudes. Okay? And with that, you can find a lot of other optional things. So, in looking at this, let's take a look at kind of some relational things and identities that you can get from this. So if we've got a straight line here that's actually the two vectors, u and v, all right, and so here's theta. I don't have much room, so we'll look at these two at a time. Let's say this one's u and this one is v. So theta is here. then what you've actually got happening is the following. If you think about this in terms of what we see happening, theta here is pi, right? Because it makes a straight line. And what is the cosine of pi? It's -1. Okay? So in this particular relationship, if you're looking at this happening here, if you know that angle, you can find what the equivalent amount is. That's the idea with these properties, okay? So in this particular situation, if this is theta, then you know that that has to be in between. So theta is in between over here, which is going to be pi. I should say here. Okay? And here, straight up and down, which is pi over 2. So in this particular situation, more or less you're thinking about it in terms of 2 dimensionals. It would be the second quadrant, okay? So it's in between 90 degrees and 180 degrees. And in that particular case, what's going to happen is when you take the dot product of u and v, you are going to get a value that is less than 0. So when you know those relationships are happening, that's what you can do. You'll know that that is also the case. Let's look at a couple more. If you've got a right angle formed by your vectors, so if this is u, that's v, that means theta is here. So when theta equals pi over 2, then that means cosine of theta is, well, what's cosine of pi over 2? It's 0. In this circumstance, where you've got u here, v here, theta here, you also have, as you noticed, an acute angle, which means theta has to be in between 0 and pi over 2, which also then means that the cosine of theta, you automatically know, is going to be in between 0 and 1. Why? Well, because cosine of theta is 1 right here, and it's 0 up here. So it's got to be somewhere in between. All right. Let's see. And then the last one is if they're both going the same direction. So in other words, if u is here and v is here. Well, here again, you've got almost the same kind of situation here, but it's opposite, right? So if this was 180 or pi, that's going to be 0. And the cosine of 0 is 1. Now, there's a special term that we refer to when we're talking about these particular vectors here. You'll notice they make a right angle. These are also called orthogonal vectors. Okay? So that's another phrase used to describe them that make a right angle, or vectors that are perpendicular to each other. So orthogonal vectors are vectors that are perpendicular to each other. Okay. We get about 10 minutes on this, so I am going to pause the video here. Let me back up out of the way. And I'm going to continue with the next video with an example of finding an angle between two vectors and an alternate form of the dot product.